So the name of this lesson is called Getting Zeroed In. The state standard is understand the relationships between zeros and factors of polynomials. Okay, so to give a little background, this is the third part of the lesson that I prepared. So I want to just share what we did in the first two parts of the lesson. So as groups, I would have paired everybody off and give like three pictures of one a quadratic equation, one a function that was written out, and then one a verb or like a word that said quadratic equations, and asked everybody to get together and create a word map, putting down everything that they could remember about quadratic equations. And so after that, as a class, we would have got together and create a word map on the board, and this is an example of some of the things that we might have come up with. So we have a graph, we have factoring, some of these key terms that we're going to be using in the third part of our lesson. And then the second part of our lesson would have been a worksheet where you guys would have actually got to factor equations and then list down what the zeros were and actually write down what those would have been. So that brings us to the third part of our project, and that is helping Mr. Jones find the missing zeros. So Mr. Jones, to give a background on him, took Algebra 2 years ago. Not 2 years ago, but years ago. So he's savvy. He works at a company where he has to make job reports and put down key information, and he needs to include specific data in his job report, but he cannot remember how to factor. So that's where we come in. We need to write written instructions for him step by step that states out how he can take one of his functions and find the zeros. So we're going to take a look at two different pieces of writing. One it's okay if I were to read this, I'd say, hey, this person knows what they're talking about, but they're not including specific language and vocabulary, and if Mr. Jones doesn't have that specific language, he's going to get completely lost. So if I can have a volunteer to read the first writing prompt. Anybody want to give it a go? Mallory.
Mr. Jones, don't worry. I'll help you find the missing zeros. First, you've got to find the numbers that will multiply to 20, but add together to 12. These are 10 and 2. Now put them in the parentheses with a plus x, and you are in factored form. Your x number is the number that makes inside the parentheses 0. Try it. Now those are your zeros. You can put a dot on the number on the graph, and now you can graph. See, that wasn't so bad.
Okay, so there is some math knowledge in there. This person seems to know what they're doing, but it's kind of unclear. And if I were Mr. Jones and I haven't seen factoring in a long time, I'd be pretty confused. So now let's take a look at an alternative way to present this information. If we can have one other person read this example. Listen.
Mr. Jones, don't worry. I'll help you find the missing zeros from your polynomial. First, identify the last term in your equation. We need to find a factored pair whose product equals the last term, 20. The factor pairs of 20 are 1 and 20, 2 and 10, and 4 and 5. Choose a factor pair whose sum is equal to the second term in your polynomial, which is 12. Our factor pair is 2 and 10. Rewrite your original polynomial in factored form. X plus 2, x plus 10. Remember that a 0 is the value of x in each parenthesis that makes the inside 0. For example, when x equals -2, we have -2 plus 2 times -2 plus 10, which equals 0 times 8, or 0. We found a 0. Using the same process, our other 0 is -10. Now you can graph your function. Our zeros are -2 and -10.
Okay, so we have more explicit instructions. We actually split it up into different steps for Mr. Jones. I think he'd be able to figure out how to factor his function with this type of description. So go ahead, and each of you guys got a sheet. Actually, this is for groups of 2. So either groups of 2 or 3. Get together and discuss the two writing prompts and the differences you noticed between the two. And we'll do that for maybe about a minute.
The second one included number examples. The first one was kind of confusing. As I read read it, I kind of got lost. I didn't know where they got the 20 from and stuff like that. They didn't say, like, from that part, like here it would be 10. They didn't say from the last.
Yeah, I really like the definitions it used. How it said we had a first coefficient, a second, and a third.
Did too. And then I like that it said first do that. And like, so the first definition just automatically gave us 2 times 10 or 2 and 10 as our numbers, but they didn't explain why the other things for 10 didn't work, so like, or for 20, so like the 4 and 5 and stuff like that. So the second one was clear why it was 2 and 10 and not 4 and 5.
Okay, so can I have a couple examples, certain things that people talked about in their groups about what the differences were between the 2 writing prompts?
The second example used numbers, step 1, step 2, which was very helpful.
Good, so they listed out specifically their steps. I saw another hand.
The second one used more academic language like polynomial and factor and product, graph,
Good, yeah.
descriptive words.
So yeah, descriptive and specific words so Mr. Jones could follow along. Exactly. So now our goal is to write out directions for Mr. Jones with a different problem, a specific problem that he's going to get for his work. So one thing to remember, be explicit. Use specific language. So here, I'm sure some of you guys have seen this before. This prompt was to find X. Well, if we don't use explicit language, we might get a smart aleck that says, well, here it is. So we want to avoid that. We want to actually be able to solve our problems. So a guide to this assignment is to include specific math vocabulary. You can use, I'll project the word map that we did in the first part of class up on the screen so you guys can refer back to that terminology. States your zeros. So go ahead and actually factor our polynomial. And then use a step-by-step process. We saw with our examples that having explicit in steps actually helped us understand what we were reading. If you are more comfortable with paragraph form, that's okay. Just make sure that your steps are clear. And go ahead and it says graph your function, but actually if you just plot the zeros on your coordinate plane, that's good enough for me. Okay, so I'll go ahead and project that. Go ahead and get with your partners and write out specific steps after you factor your polynomial.
This? Oh, right. I'm like, of course.
All right. So,
what does he want to do?
so number
He wants us
one.
to find zeros.
My lesson is on zeros.
So we're trying to find like the right
Okay, alright, fine.
plus or minus, right? So that's what you want to. That's what you want to look like.
Yeah.
Okay. Do you know how I got here? So I always use the last term and try to figure out the factors of 10. So you can't do 2 and 5 because that won't equal 9. That's how you.
It has to equal it. Okay.
Okay, yeah. So but you can do 9 and 1, but 9 has to be positive. So this has to be positive and 9.
Factors of 9.
What did these 2 terms tell you when you multiply these together? Which term does it have to be?
It has to equal 10.
So that would say. Okay.
So
Wait
these
a
2
minute.
numbers, see it?
I'm close. Yeah.
And what do they have to add up to?
9 times 1.
9.
Exactly, positive 9. So what 2 numbers multiply to be negative 10, but add to be positive 9?
Factors.
Okay, I'm close.
Multiply to be a negative.
Oh, negative 10. No. Positive 10.
Yeah, but it's passive voice. Language arts, no passive.
Choose the factors that.
Start again.
I don't know.
Wow. You think?
Yeah.
It's 10 and
Or,
1.
I'm sure this has a word. So is it negative 1?
Yeah.
Yay!
I mean, I was on the right track. I was off a digit there, a couple digits.
Okay.
Actually,
negative and a positive.
Yeah.
The sum add up to
equals.
Yeah,
You have
so
to
like
set them
what
to
two
equal to
numbers
0.
would multiply to 10?
Yeah.
Or negative 10.
And then it winds up being the opposite number.
That's the opposite. Right.
Oh my gosh. I'm Mr. Jones.
Yeah.
To calculate with you. It's been a while.
Like, I did know this one.
It's just a calculus.
It's just forget.
Oh, it's just easy. Oh my gosh. Okay, so that was
Okay,
good.
let's spend about 1 more minute finishing up your writing, and then we'll get together and talk about what it is.
Factor, then you FOIL. First you factor the equation. This is factoring right here.
Yeah, that would make sense. I did the equation.
I remember foil.
Right.
It's been a lot of years.
Now, but I think
So I
you
guess
do
it would
it
be
by using the FOIL method.
10 times 1, 10 minus 1 is 9. Right? So it's still
It's been 4 years since I've taken that.
But to factor,
All right, let's go ahead and bring our discussions back in. So, first of all, what did we get for our factors? Anybody come up with a factor form? Dan, what did you get?
1 and 10.
And is it positive or negative for those numbers? Riley, can you help us out?
It's going to be -1 and a positive 10.
Yes, -1 and positive 10, good. Okay, so now that we have our writing done, let's go ahead and swap with another group. We're going to take a look at a group's writing. Go ahead, when you're looking at another group's writing, see if there's any language that you could change or bring in some more academic words to make it more clear so that Mr. Jones can understand exactly what your instructions are saying. So if you could, switch with another group.
I know. Yeah, good job.
Yeah, we have one sentence.
All right. Well, we have 2 crossed out.
Okay. This group needs more time.
Yeah.
Yes, some more academic language and more time. Okay.
But okay, doesn't FOIL go the other way, right? Like if you have 2, you can FOIL to get this. So you can't. You want to like backwards
remember
FOIL.
those.
Yeah, foil is when you have it in the front.
Right, and you first outer last, and then you get this.
Okay. Well,
So you don't
have done.
Okay.
This is
But hey, so you don't tried, right?
it's
So
been 4 years, okay?
I only learned it from OSB. Then I was like, I don't know.
good job. You guys got the answer.
So cross out the foil part.
Cross out the FOIL part.
Well, it's not wrong. I mean, it's important.
But it's not what we're supposed to do.
That's not what you're supposed to do. So
No,
cross
you
out
solved
the
the
FOIL.
equation. Yeah, so we actually solved the equation, then we started to write the steps, but it didn't get done as the steps. Well, we as in.
She didn't want to be partner. She's the lazy 6th grader. I'm just kidding. She's the new kid.
She's just, yeah, she's trying to catch up. Paired her with the stronger student, right?
Got it, okay. I'm the gifted one. 1 more minute.
What's the difference?
Okay, let's go ahead and wrap up our editing. Hold on to the paper that you have there so we can kind of anonymously do this. Is there anybody that has another group's paper that they thought was really well written that Mr. Jones could explain and wants to share with the group? Yeah? Okay, could you go ahead and read off the instructions that we have?
Okay, sure. First, look at your last term and list its factor pairs. 1 times 10, 2 times 5. Second, we choose a pair that adds up to the middle term, but since the last term is negative, one of our factor pairs will be negative. So, which factor pair will fit this subtraction? And it's blanks with a minus in between equals 9. That shows it's 10 minus 9, or 10 and negative 1. So those can go into our factoring, and you have x plus 10, x minus 1. Last, our zeros are the values of x that make either of these